Good morning. Gotta pin my video. Morning, everybody.
Good morning. Good morning, Mr. Rosenthal.
Solve and graph.
Hello, Mr. Rosenthal.
Good morning. I made this one myself.
Cool.
Good for you.
Oh, thanks.
That's cool. Do you have a Snapple fact for us today?
Not yet, but I will.
Better get us some facts or else.
I missed it all the other days, so.
What have you been doing? Playing Fortnite?
They're all in the videos.
Literally.
Is this chapter 9?
Yes, 9-1.
Okay.
Everett, turn your camera off.
This is complicated.
Work through it with what you've been learning. All right, here comes the Snapple fact.
Snapple fact.
Snapple fact.
Okay. 1,100,000. No. 111,111,111 times 111,111,111 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, which is
Wait, really?
12 quadrillion, 345 trillion, 678 billion, 987. No. Hold on. I think I got that wrong. Million, billion, trillion. 12 quadrillion, 345 trillion, 678 billion, 987 million, 654,321.
What is that?
Wow.
Comes after quadrillion.
Quintillion.
What comes after
Quintillion,
that?
sextillion.
Look it up.
Okay.
Use all the Greek prefixes.
It's septillion, octillion, nonillion, decillion.
Greek yogurt?
Decillion.
I think you jumped over the 7.
Decillion, and tridecillion.
Oh, sextillion, septillion, octillion, nonillion. Look like that.
12 ounces of Greek
Insert
yogurt.
joke here.
Mm-hmm. We're starting in about 2 minutes, but you guys are welcome to do the warm-up.
Tribute.
Are we supposed to solve it without multiplying or dividing by a negative number?
No, there's no rules. Solve and graph.
Okay.
Solve and graph. 30 participants. 31, 32. Good morning.
Quick question.
Rosenthal.
Quick question. Good morning.
So for distributing, is 3x plus 5 already distributed?
I wouldn't say it's already distributed. I wouldn't word it that way. It's just a group that's being subtracted,
Okay.
but the entire group is being subtracted, not just the 3x. So you have to consider that. If the entire thing is being subtracted, then this subtraction must distribute to both of these. You are subtracting this and you're subtracting that.
Okay, and also, can you add the like terms on one side of a statement?
You should. You
Okay.
should. You
That
should.
makes it less complicated. Thank you.
You can and you should.
And Mr. Rosenthal, you have to flip the equality sign. I mean, like, if the inequality sign, if, hold on. You have to flip the inequality sign only if the
Numbers.
divisor is negative, correct?
Or you multiply by a negative.
Yes. But like when you're dividing, if the dividend is negative, you don't flip it, or
Wherever you start, whether a value starts on the left of 0 or on the right of 0, no matter where, if you multiply or divide, if the divisor is negative, it's going to change to the other side. If your action is to multiply or divide by a negative,
yes.
it will take anything that's on the left of 0 and it will place the result on the right somewhere. And if it's on the right, when you do that, it'll place it to the left. Okay? So then the arrow will switch when you do that.
Got it.
Was the Snapple fact already said?
Yes, you'll have to go to the video. Okay, 10 o'clock, we can do the problem. Here we go, ready. Distribution, 12x minus 9. Distribute the minus sign, minus 3x minus 5. Less than, distribute 20x plus 8. So that's a little distribution review right there that everybody should be comfortable with.
You can distribute signs?
Well, how many of these groups do you see?
3.
Let's just take this on its own. I'll erase this in a second. You're subtracting the group, right? How many of this group do you see here? One of them.
1.
Okay, I can change that to add negative. Now.
So that means
-1.
So it's like you say with the x's, when you just see 1x, you think it's 0, but in reality it's 1.
Good. Yes.
So that means if you see a negative or just a symbol by itself, you can just imagine a 1 after that and then multiply it.
And by -1, see? Subtracting 1 is the same as adding -1, and so you can distribute -1 to both.
Okay.
But then you don't need to write that out like that. Now, if you see that, you can distribute the minus to both.
That's why, like in a subtraction problem like this, you can if it's like 5 minus 3, you can do it 5 plus -3.
Mm-hmm. Okay, look at this. 9x. This one and this one is -14.
Right.
Mr. Rosenthal?
Mm-hmm.
So when there's two in parentheses, when there's two things in parentheses and there's not, and it's just minus, but there's one number in the front, you just distribute that to all of them?
Can you please rephrase that question?
It's hard to. So if there's only one number in front of, and there's two things in parentheses, then you distribute that one number to all of them, right?
Yeah, and it doesn't just mean 2. It could be 50,000 items being added, and the 3 would distribute to all 50,000 of them.
Yeah.
Because it's 3 of the entire group. Think of this as a bag of gems. 4 of this type of gem, take away 3 of some other type of gem. Maybe it's a little piece of paper that says if you pick this up, you owe somebody $3, right? You take 3 of the same bags. Well, you're going to owe somebody $3 3 times. So you're going to owe them 9. You're also going to have 4 of something in each bag. So you're going to have 3 of those bags. So you're going to have 12 of that thing. That's how that works.
Okay.
Okay, let's get back here. Variables on different sides. So you can bring the 20 over here, or you can bring the 9 over here. Okay, that's really just a matter of preference. So if you like the variable on the left, especially in these inequality problems, bring the 20 over. If you really don't want to get a negative because you're going to subtract 20x from 9x, and you don't want to avoid that, then you have to pick which one you want to deal with. Okay, so let's get a negative. Negative 11x minus 14, that just comes down, less than, that just comes down, 8. Okay, that down. Okay, now we have x on one side and no x on the other side. That's great. Now we can get all the rest of the numbers away. So let's add the 14. Negative 11x less than 22. And then finally, I'm going to take this and I'm going to divide by a negative. And when you divide by a negative, it's going to switch this. And then this will be negative 2. Okay, x is greater than negative 2. So the graph, here's your negative 2, here's your negative 3, here's your negative 1. It's an open circle, greater than is that way. Okay, any questions about that?
If the variable is on the left side, wait, what's that trick that you did where it's like the variable's on the left side and whatever way the arrow's going is the way that you graph it?
I didn't give anybody a trick. Some students were doing it that way. I told them, be careful, understand, don't learn this via trick. You don't want to learn too many tricks here. You just want to really
And the
understand.
algorithm.
You don't want
Just kidding. Just kidding.
the algorithm's fine, or a trick or an algorithm is fine, but that comes secondary. Primarily, I need you to just understand what it means. Okay.
Piece everything together.
So I'm going to erase this, and I'm going to just review that with you.
Wait, 'cause I have a question.
Yes.
So after I did all the distributing, I got hang on, I didn't account for the negatives. Never mind. Give me a sec.
Hey, Mr. Rosenthal.
Yes.
For the equation that you wrote in the beginning, you wrote for I think it was from black to green. You got the plus sign and the minus sign wrong, I think.
Well, we'll never know now unless we go back to the video. I didn't have a copy of this on the screen, so that's why I like the smart board. I could have just gone back.
Okay, I found it.
But I don't think that I did. But it's possible.
No, you did it correctly because you distributed the negative sign.
Yeah. So
Mr. Rosenthal, I found what I did. So I got 9x plus 8 and then 20x plus 2. Is that correct so far?
I don't have it anymore.
Dang it.
It's
I
not.
have it.
It's look. If you look, I don't have it like normal. I didn't get it from the screen. I just made up a problem for you guys to do this time. So unfortunately, now here's the one thing one thing I want you to take away is this. If I switch these, if x is bigger than that, then that is smaller than x. And see how would you graph it? Are there two different ways to graph it? No, they mean the same thing. Here's your negative 2. Here's your negative 3. Here's your negative 1. Okay? If you had it this way, some students will shade the wrong way. This one has to be shaded that way. So you can make up any rules you want. Some students say, well, if the variable's on the left, follow the direction of the arrow, shade it the direction of the arrow. fine if you want to remember it that way, but that's really avoiding understanding what this is saying. What I am shading is x. What I am shading has to be to the right of that, okay? Then when I read this one, is that -2 has to be to the left of what I am shading. Here, -2 is to the left of the shaded part. See it? So you can read it either way, and you have to understand it both ways, okay, instead of remembering tricks. Okay, that being said, we're going to get back to where we left off. Okay, let's take a look at this. Here's a coordinate plane, y's and x's. It's basically 2 number lines is all it is. And so you don't just get to stay on the 2 number lines, you actually get to move out here. And each one of those has an x and a y coordinate. How are the x and the y related to each other? They're not separate. You don't say, there's x1, and up here, there's y1, and there are not 2 separate points there, are they? These are not 2 separate things.
No.
These 2 are related to that location in the plane.
What does the 1 mean?
So first of all, let's understand, just because I'm going to make another point, x2,
Oh, okay.
y2, right? x1, y1, x2, y2, here's x3, y3. They're just in different locations. So what is a point? What is that? What's a point? A point's a location in space or on a plane. Okay, so first understanding what a point is, in a plane, taking this point, that location is coded. It has a, how do we know where that is relative to the origin? You need to have a reference, a frame of reference. A reference point would be the origin, 0, 0. From some reference point, 0, 0, this exists somewhere. We can say it's in quadrant 1. You'll have other x and y's. Here's x4, y4 over here in quadrant 2. Okay, and some in quadrant 3, and some over here in quadrant 4. Okay, so points are locations, and every location is unique. Every location is unique. Just like on a single number line, every location on a number line is unique. Okay, so a point, you can't have 2 numbers that are in the same location at the same time. So every location here has an x and a y that go together. That's how they're related. So we say that a set of points is called this. A set of points is called, anybody know? What is a set of points called?
A coordinate?
Coordinates.
A relation.
A relation.
Huh?
I got it.
Yeah, a relation is a set of points. Why? Because points relate x to y. It makes them have a relationship with each other. To represent
Everything has to have a point.
every point on the plane is made up of an xy. You can't have a point, even if you're on an axis. What happens if I'm right on the x-axis? What happens if I'm right there? That has some x value and y is 0.
Y is 0.
Yeah, that still has a y value though. You cannot just say x is x by itself. Every location has an x and a y. So that
Yeah,
is,
but there are some things that don't have a point value in like quantum physics and stuff.
you're
There's
talking about imaginary planes maybe, I don't know. Like where's this point on that plane? This point out here. Where is that on this plane? It
It's-
doesn't exist on this
it's-
plane. Okay, so it's in the null space. All right, you're in some null space that doesn't exist with respect to this plane, but it does exist out here, okay, in some imaginary space. But we're not going to get into that right now. I need everybody to understand what a relation is. It's a set of points. It could be 1 point. It could be a bunch of points. There could be a pattern with the points. I could have a bunch of points that all follow a rule called a locus of points. It's still a relation. It's still a set of points. They don't have to follow a rule. They could just be randomly scattered points. with different X's and Y's. All right, so I bring you back to last semester. You had a chapter or two, I think a couple chapters, where we talked about domain and range. What was domain?
Domain is the x-axis, right?
Not the X.
X value.
X value.
Uh,
Not the X
value.
value
The
exactly.
the domain is the possible x values, and the range is the
Those
possible
all-
y values.
Indeed.
It's the set of X's that are in your relation. Okay?
It's not.
Range is what Y can be. Okay? The range is what Y can be. All right? X's represent the independent what?
Variable.
The independent variable. So we basically take from what X is allowed to be, and then we see what Y is going to depend on that.
Yeah.
Independent variable.
Y depends on X. Dependent.
Non-variable.
variable.
Like science.
All right? And so this is what's going to help us define, look up here, what a function is. A function is a relation. Now the book fell down right here. The book used a vocabulary term without saying what a relation was. They needed to remind you what a relation was. Okay?
It's in a piece book.
So now we know what a relation is. A relation is a set of points where the X's and the Y's are related because they are points. Turn off your videos.
Can X be anything?
Kieran.
You guys need to mute your stuff.
Kieran.
Who's watching Laser Beam?
Van, mute yourself.
Guys, hey.
That's
You don't
good.
handle it. I will handle it. It gets messy when you guys try to handle it. I just will say mute. That's it. And it's done. Okay? All right, no arguing. All right, so here we go. Now we know what a relation is. We can talk about a function. A function. Let's go ahead and read that. That just came off. It'll come back on right now. A function is a relation in which each element, get that back to full screen, each element of the domain is paired with exactly one element of the range. Okay, so if I plug in an X here, I'm gonna help you here. I'm gonna draw a machine. Watch this. I'm gonna draw a machine. It's gonna be a weird looking machine.
Oh, a machine. That's one weird looking machine.
Okay, this is where my inputs go. My inputs go into, we'll call this the function machine.
Old camera.
I knew somebody was going to say it looks like a camera. You put an X value, here's an X value, X1, or you have to take from the set, from the domain.
It's clearly a projector.
X2, X3, ... Pick whatever's in the set that you can pick. You put in whatever you want. That's why it's independent. You get to pick. You're free to pick whatever you want. Once you put it into the machine.
Can the input be anything?
The what?
Can the input be anything?
Anything from the domain. And often it can be anything. It can be any real number often. Most of the time we're going to be able to pick any real thing. But what if the X is on a denominator? What can X not be?
0.
Can't be 0. So sometimes things get eliminated from what you're allowed to use. So
X has limitations.
yeah, you have some limitations. Okay, so let's get to the point of my function machine. Is if I put something in, what the function does is it allows me to predict what's going to come out. That's what the usefulness of a function is. The usefulness of a function is predictability. So if I know that if I put x1 in, let's say I put x1 in, I'm going to get y1 out, my output. Inputs and outputs. Okay, and these form your range. This is what your range values are made out of. It's all your outputs, and the outputs are dependent on what your inputs are.
Is this like the charts that we were doing and how we got E like that? Because it was an input and output.
Yeah, a lot of what we're doing is input and output. Now, listen to this. When would this stop being a function machine? If you put
When the X's aren't the same.
If
you put in 0?
Okay, let's expand on that. when do you lose predictability? What would have to happen for you to not be able to predict what's going to come out of the machine?
When there's no
If there's
function?
no function,
What happens
Which
if
means the x's aren't the same.
let's say I put
No
in
relation.
when the x's are the same.
let's say I put in
Yeah.
x1 and sometimes I get this answer, but other times randomly I get some other answer from the same input. And you
Then
don't know which one's going to come out.
Oh.
Then what do you lose? You lose your ability to predict. Now it's not a function anymore.
Predictability.
Okay? So that's what this is saying in the definition. A function is a relation, which is a set of x's and y's. So we got our x's and y's, in which each element of the domain, anything I put in, has to go with exactly one answer. Okay? All right, now, let me ask you, what if I put in x2 here? And I get out the same answer that I got when I put in y1, but I always get the answer. If I put in x1, I always get y1. Or if I put in x2, I always get y1.
Well, then that means that x1 and x2 are equal, which means
Let
that.
me ask you, do you know it doesn't mean they're equal,
Oh, okay.
right? Let's say that if I'm 18 years old, I get to vote is the output. If I'm 19 years old, I get to vote. If I'm 20 years old,
It's an
I get to vote.
inequality.
Right? If I'm
Not an
17 years
equation.
old, if I'm 17 years old, I don't get to vote. It's predictable, isn't it?
Yes.
If it is predictable and you know for sure when you put something in, you're going to get something out, it's a function. So is it a function if I put in two different x's, but I get the same answer every time, even though there are different x's, I get the same answer?
The function is the
Let
inequality.
me ask,
Is an inequality.
is it still a function?
Yes.
Yes,
It
because
is.
you can predict.
So yes, so that's the number one way to think about if it's a I'm going to be asking you, is it a function? Is it not a function? There's lots of ways that they're going to try to confuse you. The easiest way to do this is the answer, did I lose my predictability for the output? Okay? All right, so let's move on and start looking at how they're going to ask.
The only time that it's not.
Yeah, go on. Go on. Uh-oh. Did I lose you guys?
The only time that, like. Wait, what?
Go ahead.
The only time that you lose predictability is if one x value can, like,
Make more than one output.
can, like,
right. Yes.
yeah,
That's right. That's the
can
only
get
time is
two
when
y values.
you put in an x value and you're not sure what's going to come out. All right. So let's look at this up above. If I put in a 2, I get out a 1. Predictable? Yes. If I put in a 4, I get a 3 every time. Here, if I put a 5, I get a 4. Predictable. Here, if I put a 9, I get a 7. That's predictable. This is a function. This is not a function. Even though some of the elements, some of the inputs have predictable outputs, not all of the inputs have predictable outputs. So it can't be a function unless all of the elements that are in there have predictable outputs. Okay? And look, when you put in a 2, you can get out 2 different results. When you put in a 2 into your machine, you can get out 2 different answers. So therefore, Galileo, you have to stop doing your video. Okay, there's a couple of you that daily now you keep putting your video on and off. It's really not funny. I need you to stop doing that, or I'm gonna have to remove you for a day.
That's a picture.
Please don't. Now, if you have a problem where you have some issue, it's doing that, you don't mean to be doing that, then let me know. Otherwise, please don't do that.
That's a
Picture.
That's a picture.
That's just
Not a video. It's just a picture.
That's just a picture.
His video turns on sometimes. I can see
No,
it.
it doesn't.
I don't understand.
Doesn't matter. We're not going to discuss it.
Doesn't.
Okay. This is a function because each domain value is paired with exactly one range value. That's a typo. It should say 1 right here. This one was not a function because 2 in the domain is paired with 2 range values. Okay. Another one, let me show you here. You can make these. These are called input-output tables. Input-output tables. What if I have this input-output table? So I have this, and I have, let's do 1, 2, 3, 4, and then I have 5, 6, 7. Is that a function?
Yes.
Yes.
So look
Yes.
at you can see why does this one get confused with this one?
No, this is
Because there's one y value that's equal to like that. It's a function with two x values, but
This is not a function.
yeah.
This one is. And the way students get that confused when they don't realize the predictability part of the definition.
In the one that's is not a function, the x value has two y values assigned to it.
So then
But
you
in
look,
the other one, there's two x values assigned to one y
yeah,
value.
and the
That's
easy way to
still
think
a
about it is
function.
if I ask you, what do you get out of it when you put in a 2? What would your answer be here?
Here
No,
you
up here.
won't know. You wouldn't know.
You don't know.
No.
It could be 1,
One
or it
or
could be 3, and you don't know. That's how you can test. It's a little test you can do for yourself.
50-50 chance.
Here, if I put in a 1, what am I going to get?
Oh, 5.
Is there anything else I can get when I put in a 1?
No.
If I put in a 2, what am I going to get?
5.
5. Is there
A
anything?
5.
Is there anything else I can get if I put in a 2?
No.
No. Okay.
No.
So this one
That's a
maintains.
function.
This one maintains predictability, so it functions. Graphically, what would that look like? Now, I don't know. Probably some of my slides already do it, so I'm kind of getting ahead.
It would, if you graph it, it would then
If I
there
graph
would be
this point here, 1, 2, 1, 2, 3, 4. This coordinate is 2, 4. This coordinate is 2, 2. Is that a function?
yeah.
No.
No,
No,
it's not.
never mind,
No, it's
never mind.
not.
Inputs
No.
are your outputs.
No, it's
That
not.
means if I say if x is 2, how many different answers are there that you can get for y?
There are
2,
2.
4, and 2.
There are 2, so not a
a function.
If they're on the same y, like if they're on the same y plane but there are different x's, then that's a
So
function.
we have a
But if it's-
graphical test. Graphically, there's a test. It's called
Yeah.
the vertical line test. Take your pencil, put it on the graph. If it touches more than one point at a time, it's not a function because the x value 2 has 2 different y values.
Yeah.
All right, let me test you with a different graph.
Yeah.
Mr. Rosenthal.
You can just sketch a graph. You don't even need numbers. You can make a little coordinate plane on your paper right now and go and make a line. I'll put up 3 different lines and ask you. A negatively sloping line, a positively sloping line. Oh, 4 different lines. Let's do a horizontal line. This is probably going to be a slide coming up later. But oh well, if we do it early, it'll be under. I feel like talking about it now to connect it. So let's do it now, and then we can just skip it later. And a vertical line. Which of these are functions and which one is not? Are there any that are not a function? Here, let's talk about pink. Hold up your pencil.
The pink one is not
Pink
a
one.
function.
If I go anywhere, my marker is, let's say I hover my marker over that point. There is no other point above or below it, is there?
It's a
No.
function.
No.
Oh,
Yeah.
so anywhere I go, let's say I take my marker to here. It's crossing right there, okay? So there's no other point above or below it anywhere. All right, so that is a function. Function in
Is
pink.
that a pink line or is it a purple?
Purple.
Yeah, it looks purple.
Well, look at it compared to the other
It's
one.
red.
No,
This
but
one's purple.
one of them looks
Hey,
pink.
now look.
green.
All right, let's go to a negatively sloping line. This is the purple one. Also, at any point that I want to stop at,
It's a function.
there are no other points on just talking about purple only. There's no points above or below any of these other points. So
It's
the purple
linear.
one is a function.
It is a function.
Yeah. Let's look at the horizontal line.
Oh,
Annie,
that one.
That's the one that you were talking about that people get confused with. That's like not a fun like. it
oh,
is a
you're right.
function.
Mr.
Because look,
Rosenthal, I'm so sorry to interrupt you. This is
Yeah.
Everett's mom, and I cannot hear you. But I'm just wondering, every 20 minutes, could you please remind the kids to take a 20-second break from the screens? Because Everett is just glued to this thing.
oh, if I can remember, I mean, if anybody wants to remind me to do a break, I get kind of caught up in this. So,
I can do it.
yeah.
Oh, yeah.
And also remember, I am going to post this online later. So if you don't remind me, if you don't happen to remind me and you take a break,
Thank you.
yeah, definitely. Okay.
So it's like a brain break or something, or
Yeah, I guess we can do that.
or just arresting your eyes.
Yeah. You can look away now if you want to look away.
Oh yeah, that's 2020. Yeah, it's a common thing for people with glasses, because you need to like if you're 20 minutes
Read.
looking at something, then you have to take 20 seconds to look away.
All right, let's come back. Now, I don't know who said it. I think was it Galileo that said that?
What?
This was like that example that people
That
get.
was me. That was me.
Yes.
Jasper? Yeah, because let's say x is 1 here. Y is this value. If x is 2, y is that value. If x is 5, y is that value. So whatever x you put in, y is that same value. But that's okay. It's predictable, isn't it? Right?
So any
Yes, it
horizontal
is.
line is, or any vertical line is not a function.
Only because x is the
More than one is x is one place, but y is more than one place.
Yeah, watch this. Let's
Yeah.
say here is 6. If x is 6, what's the y value?
1,
It could be
2,
here.
3,
It could be
4,
here. It
5.
could be here. It could be here.
Yeah.
All of those are x is 6. When x is 6, y has infinite values, and you don't know which one that it's going to be. So the vertical line
random.
fails the vertical line test. Okay, so this one is the one that's not a function.
Oh, is that why it's called the vertical line test?
Yeah, because you're literally putting your pencil and seeing if you hit more than 1 point. Okay, then it's not a function.
It's one location of x, but it's multiple locations of
Some
y.
video game sound. They need to mute it now. By the way, this one is a function.
Yeah.
By the way, I just want to let you know, with the older group, I never have to tell them to mute or do those things. I never have to do that. Okay, so please try to take that example from the older group. It does get in the way. Okay.
So they're all functions except for the vertical line.
Okay, any other questions about what you're looking at here in terms of what's a function, what's not a function?
On
Yeah.
on the one that's not a function on the vertical line, I'm just confused, like overall on that. Like,
Let me ask you about, then let's go back to the base test. Does it have predictability in a machine where you put in the x and get out a y? So if x is 6, let me ask you, Charlie, do you know what y is going to be?
No.
Okay. What about in the orange one? All right. If I tell you x is 1, do you know what y is going to be? Or is there more than one thing y can be here? It has to be only there, right?
Yeah.
Okay. If x is 2, y has to be there. You know it's going to be there.
Yeah.
Okay, so this has predictability. The pink and the purple, same thing. For every x, there's only one y value that goes with each one.
Okay.
Okay?
Wait, so the reason that the one can't match with the second orange dot is because they have to match with like what I just forgot what you said. But yeah, I understand.
Go back to the function machine. When you put in an x, you pick the x you want to put in, and then you look at what the y is. Could there be more than one y? If the answer is yes, it's not a function because you don't know which y you're going to get.
Okay.
But if there's only one y for that x that you put in, it is a function. So for
Okay.
purple, pink, and orange, that's the case. There's only one y for each x. Hear the dog barking? That mic must be muted. Okay. One more thing. Other types of graphs you're going to see coming up in algebra other than, so in our class, lines are fine. Okay, but in next year's class, you're gonna have
Is that a
parabola
parabola?
or parabolas functions.
What's a parabola function?
It's
I
when
didn't say it's a parabola function.
it is a
Ask
function
you
because
if the parabola is a function. The
you
equation,
It's like
create
Satan's
it.
spear.
hold on. The
You
equation
create it.
would be like,
Y equals x squared.
maybe it's
Minus.
something like that. Okay.
Yeah.
Is that
But-
a function or not?
A
Yes,
parabola
it
should
is.
always be a function, right? Because a parabola can never be perfectly vertical.
Yes.
Right. This
It
exactly.
gets infinitely
God.
straighter, but it doesn't go as a perfect vertical line.
Every time you move over, it increases the amount of, its
Both
elevation,
x and y.
but it never goes up without moving your x over. You always go up, you must move your x over a little bit at least. So it never goes straight up and down. So because it
Yes.
never ends up going straight up and down, it is a function.
Yeah.
What about this?
Just because.
What
And
about
sure does it end up going straight up and down?
now watch this. What
Then
if
it's
I
not a
have
parabola.
x? You guys, hold on for a sec. What if x is equal to y squared? Okay.
That's not a function.
It turns it on its side.
Yeah, it's not a
Now,
function
you fail the vertical line test.
because that's more than 1 point. Yeah.
See? If x is, let's say, -2 here,
Easy.
then your y could be here,
Right.
or it can be here.
It's not.
Not a function. What about a circle? What do you think the equation for a circle is? It's the Pythagorean theorem. That's something to think about.
B squared.
The number that goes there is your radius squared for your circle. A squared plus B squared equals C squared is the equation of a circle. So let's say you have a circle in blue. It fails. It fails the vertical line test. 2 points.
Like all points.
Okay. So that's gonna fail. All right. Maybe the 1 point on the end. The 1 point on the end passes, but all of it has to pass. Or else,
Like just because an equation isn't linear doesn't mean that it still isn't a function, because like the parabola, it is a function, but it's not linear.
right. And even just a set of points, random points, you can say is a function. So this one, and that one, and that one. Is that a function?
Yes,
Yeah.
because you can predict. There's no vertical. There's no same values of x but different values of y.
Yeah. X1 gives you Y1. X2 will give you Y2. X3 will give you Y3. X4 gives you Y4. Okay?
But if x1,
yeah, every X goes to one Y only.
yeah, if like x1 gave you y1 or y2, then that's not a function.
Exactly. And then you would see visually, 2 points vertically from each other.
Yeah.
Okay. I think you guys are following. Go ahead and take another eye break while I'm going to the next page. Okay, I will probably shrink down to, let's say, let's go to 215. There we go. All right, I want you to answer this question. Determine whether each relation is a function. Let's just do A and B for now. Okay, and I'll give you 2 minutes. Go. Oh, you don't need 2 minutes. You can quickly, 30 seconds. You should be able to get both of these in 30 seconds. Remember, X, Y, X, Y, X, Y. Here are your X's that go with these Y's.
Do we just write not a function?
Yeah, not a function or function. Anybody need more time?
What does the last one on A say? What's the last?
56, 128.
And the second one says 56 also?
Yes?
Okay.
You just gave a hint.
Yeah, kind of, but that's good. No, that's okay. All righty then. Okay. Write in your comment area whether you think A is a function. Just write it. Don't say it. Let me just see. I'm going to just look at your responses. One no, two no's, a bunch of no's, a couple yeses. No. Lots of no's. Okay, I'm only asking for A. Don't give me B yet. Okay. All right. Well, if you said not a function, you're correct. Is it predictable? Well, if you put in a 54, you might get out a 112. But later on, you put in a 54.
Might get a 123.
Something else. I don't need to look for anything else. Even though there's another example of that, it's already not a function automatically now. You've lost predictability. But if you look, 56 gives you two different values. Okay, so 56 as an input does not give you a predictable output. All right, give me an answer for B, function or just yes or no. Yes is function, no is not a function. Lost this entire discussion train of thought.
For number 2?
B, yes. Mostly yeses, a couple no's. Okay, let's take a look. One giveaway. X does not repeat. There's no repetition of X. So every X is unique. So that means it doesn't matter if two of the Y's repeat, by the way, which they don't either. But if X is 4, and it's only 4 once here, you get a 6. You don't get anything else. It's predictable. If you put in 4, you get out a 6. If you put in a 7, you get out a 10. If you put in 6, you get out an 11. If you put in 3, you get out an 8. If you put in 5, you get out a 4. If you put in 2, you get out a 9. It's predictable. So yes, that is a function. Now you can open up your mic and ask questions if you have.
And these are just random points on a graph. It doesn't have to be there doesn't have to be an equation representing the table.
It doesn't have to be a line or any. It could just be it can be a relation. Just a set of points. Any set of points. Okay, no questions. Let's move on.
Wait.
Okay. Yeah.
I just wanted to ask, when is the concept of a function used in like science or like in the real world?
So a function has to do with predictability. So you're asking, when do we use predictability in science? Well, that's almost everything we do in science is used to predict outcomes in the future, isn't it?
Right. If you put in one variable, you want to see what other variable comes out.
Yeah, and so we need to study patterns mathematically of what we see in physics.
So like for a projectile to see where it's going to land or when it's going to reach its peak?
There are infinite examples, basically.
Yes.
Okay, so whether that, science is looking for predictable outcomes. All right, so you're trying to fit things into a function. Now, there are things that are not functions mathematically, like circles, but they do follow a set of rules. Okay, so we will examine circles when you get to algebra, when you get to geometry, and then also further when you get to algebra 2. Okay, so we're going to get to examine those because those are useful. All right, but right now we're kind of in the linear mode. And for most of next year, you're going to be in linear mode. And then the second half of next year, you're going to get into parabolic mode.
Hello.
Okay? And that's about as far as
I wasn't using it.
What's algebra 2?
Algebra 2, you're going to start with linear and parabolas as a refresher. And then you'll go into circles, ellipses, hyperbolas, other
Then
shit.
we do physics.
And you're going to use all of that stuff in physics. Okay, here's 2 more. C and D, function or not? Go.
Do we type it into the chat?
We're still getting some of you that aren't getting that this is not a platform for you to do that kind of silliness. Certain types of silliness are fine, but ones where you're wanting everybody to hear you're drinking a fluid, that's not appropriate. So let's hold off on that, please. Okay, you guys take another 20 seconds to determine whether these are functions or not.
We write it in the chat, right?
Just do write C only in the chat.
Oh, oops.
Yes or no?
Is this lesson 9-1?
Yes.
Okay.
As you're working on these two and you're writing in your answer, I noticed that we have 55 participants each time. Okay, maybe 56 or 57, but it's around the same. That means that we have some students that are not on. What I need everybody to do is just ask people, because there's no way to know who's on for sure, but I want to start a campaign of just asking everybody you know who you have the contact information for. Are you participating in these meetings? Just ask them and tell them if they're not, tell them Mr. Rosenthal needs everybody here because I didn't say it before, but now that we're kind of seeing that this is going to go on for a lot longer than we expected, we all need to get into the mindset that this is the new reality for right now, and that so this is school, and I need everybody to start thinking about this as this is your classroom right now. It's not really optional. All right, you need to think of it as I need to be there just like I need to be in class when everything is normal. Okay, so some of the students, yes.
Something that would also help is also for everybody to change their username to their actual name, because some people are just like, we don't know who they actually are.
Yeah, that would be great if everybody could put their, and you know what, we'll talk about
shut butt.
So starting next week, starting on Monday, I would like to see everybody using their own names so that I can see who the person is. That would be great. And what I can do is if they don't do that, I can remove them. So we can do something like that.
That's what you get.
Okay. So anyway, please, when this is over, contact all the people that you have on your contact list. Put your feelers out and try. Let's have a campaign to get 100% participation. All right. Let them know that this is.
So how many
people are?
How many participants should it be?
Yeah.
Because some people are in algebra.
I should have about 75. So we're missing a good 15 to 20 students.
I think
So some people have like another
7th grader here.
We are missing, I'm talking about all of my pre-algebra students total to about 75. So all of my pre-algebra students, no matter what grade they're in, we're missing about 15 to 20. Anyway, moving on. Here we go. No. Moving on. Okay, this one is a function. The quick way to find out is, does x repeat? No. If x doesn't repeat, then everything, it shows you it has a predictable outcome. Okay, so that's C is good. That's a function.
Okay.
X does repeat. Just because it repeats does not mean it's not. What would have to be true if you see X repeat? What would have to be true to maintain its functionality? You'd have to have the same answer here as you do here. So if this said 1, 7, and this one also said 1, 7, then you're okay. But it doesn't. Here, this input of 1 gives you one output, and then later on an input of 1 gives you a different output. So that's not a function. Questions? Questions? Okay, as we move on, take another eye break. Look away from the screen for a second.
Mr. Rosenthal,
Yes.
it just slipped my mind. If it's not a function if there's a repeating number on the x or the y, on x or y.
So there's that algorithmic thinking that we need to break you of. We don't want to learn it like rules that way. I only offer them to you once you understand it. Again, let's go back to when you put in an x, your input, do you know that there's only going to be one answer that comes out of it? See what I'm saying?
Yeah.
Okay, so when you put in a 1 for x, what is your y going to be, Charlie? Go ahead. If x is 1, what's y going to be in this example?
2.
Do you see when x is 1?
Oh, 7.
Well, how do you know that it's not going to be an 8? Here I put in x as 1 and I got out a different answer. See that?
Yeah.
So you don't know. So not a function. Once you understand that, then you can come up with little tricks. I feel like students, year after year, not just you guys, it's a natural human thing. In math class, students are just waiting for the teacher to provide them the shortcut trick. And then I'll go home and study that shortcut trick, and then I'll get an A on the test, which probably works great. And then later on, you realize, oh, math is starting to get really hard. I don't understand any of it. Well, that's because you didn't build that understanding the whole time. So let's not.
You just learned the trick. You didn't learn how to do the math.
Let's just say for yourselves, only allow yourself to learn a quick shortcut trick once you get the fundamental principles behind it. Then go ahead and look for the speed. Okay, the tricks are to get you faster. Okay, tricks are good for getting you to do the problem faster, not for understanding.
Quick question.
Uh-huh.
So can this also be like proportionality, like guessing what's going to come next with a definite answer?
Yes, if something's proportional on a graph, what are the two traits it has to have?
It's the next set of data will correspond.
What are the two traits that it's going to look like, though, the graph of proportionality? What is it going to look like? It's going to be number one, it's going to be a line. Number two, it has to go through the origin. Okay? So yes, proportionality is a function, represents a function because of its predictability. Yes.
Can you come up with anything that doesn't go through the origin?
You need 3 wins.
No, that's when it goes through the origin.
Really?
Hey, you guys need to mute. I'm saying it again. You need to mute. I'm hearing background noise. Please, everybody, I'm just going to mute you're not really listening to me. So I'm going to have to mute everybody. Okay? Okay, I think we're good. Please stay on mute unless you have a question. Thank you. All right, we have a ways to go and we're running out of time. Okay, but you know, the good thing is we've already done this. Vertical line test, check, we're done. Look at that. Not a function because of these two. See, x is 7, but y has 2 different answers for an x value of 7. You can have y as 2, or you can have y as 6. Okay, so that's not a function. Okay, already did this. See, I think we've done most of the lesson. This is a function. It passes the vertical line test. Any place that I touch, it's only touching at one point. Remember, if this is a line, in geometry, we study this in the beginning of the year. 2 lines intersect at exactly one what?
Point.
Yeah, at a point. Any two lines intersect at a single point, not in 2 points. Okay, so when I'm holding up my arm, when I'm holding up
intersecting.
No, if I said if 2 lines intersect, when 2 lines intersect, so then you've already ruled out parallel lines. When 2 lines intersect, they intersect at exactly 1 point. Okay, so if I'm doing a vertical line test, you're making a line, and you're seeing how it intersects the other line. It's only going to intersect it at 1 point at a time. Okay, so that one passes the vertical line test. Okay. That's called a step function.
That work.
Is that a function or not?
No, it's not.
It's not.
No.
Damn thing I ever seen.
Because when x is 2,
I have a question.
when x is 2, y could be 1 or it could be 3. Okay.
Yeah, that's not.
How about this one? Let me give you an example of something like that. Open circle, then right up above it, closed and over, open circle. That is a step function.
What does the open circle mean again?
That means you can't be right on that point.
Oh, okay.
Okay?
So
then
it's the function.
when x, let's say this is x1, y1, x2.
Not a
What?
function.
This is a function because for an x value of 2, there's only one y value up here. y2 is right there.
Yes.
When you have x3, y3 is this point, not that point. That's not a point. It's an open circle. Okay? Now, what does this problem represent? What if I say that I want you to do some special rounding for me? Whatever decimal I give you, you round down to the nearest integer below. You always round down no matter what. Even if you're more than halfway, round down. So let's take the number 3.75. What does with that rule, what would 3.75 round to?
3,
Two.
I think.
4.
4.
Okay.
Did you say round down?
Always round down to the nearest whole number below.
3. Yeah, so that's
Up.
3.
That would round down to 3. Okay. Once you get to 4, what happens? So here, watch this. Watch this. So let's say that this was 3. This is 3.5. This is 3.9. And then right when you get down below here, that's 4. Okay? So 3, 3.5. And then let's say that this vertical distance here is 3. This vertical distance up here is 4. Okay, so when x is 3, it rounds down to 3. You get that point. When x is 3.5, you have to round 3.5 down. So it also is 3. Anything in between here, anything here rounds down to 3. Your answer is 3. If x is 3.9, it has to round down to 3. Your answer is 3.
It's still a function.
Once you get to 4, then you're allowed to jump up here to 4. When x is 4.1, 4.2, 4.3, 4.4, your answer is still 4. Once you get to 5, you jump up here. Okay, so that's how that would work.
So is the empty circle a
function
point, but it's
because-
really not a point?
It is a function because it has predictability.
Yes.
But how is the empty circle? Because if you get to the empty circle and then you skip to a different point, does that mean the empty circle is not really a point though?
Correct. That's correct.
Yeah,
It's
it's
not
just
a point.
anywhere but there.
Yeah.
Oh, so it can be anywhere but there.
Yes, exactly.
Oh,
Okay.
so it's like the force field in the.
It is a 4. Exactly. You guys are totally on top of this. Okay. Now,
Yay.
what if I always round it up? What would that
I'm a
look like?
force field.
Would it look like this? Round up. Okay.
Yeah.
In here.
Yes.
That one. Then open on the bottom to there, and then open on the here. You can do it like that, and that's a function.
Oh, it describes.
Rounding up. So if I have, so let's say x is, let's just make this.
Andy.
Make this like.
Honey?
Let's make this 1, 2, 3. 1, 2, 3. Okay. If x is 0, then your answer is 0. If x is 0.5, you round up to 1. X is 0.1, round up to 1. Always round up to the next whole number. So all of these x values will come up to 1. This x value will come up to 1. When you get to 1, you round up to 1. Once you get past 1, now you got to round up to 2. Once you get out here, you got to round up to 2. Until you get to 2, then you still round to 2. After 2, now you got to round up to 3. Okay, so that's how that would describe that type of action.
Wait,
Okay.
why are we
This
rounding?
graph represents that rule.
I'm just saying how would you get this type of graph? If somebody's saying, well, how do you even get a graph like that? It's a rounding graph. So if I'm in business and I wanted to round something up or down for business sakes, you can use that's called a step function.
Oh,
Okay,
so
really? Okay.
so if you.
Hold on, everybody. We have to move on. So step functions are not necessarily part of the curriculum. It was an extra. So if you want to ask me more about that later, you can. Okay, we're going to move on for time's sakes.
So when you round, you have an empty circle?
You can, in the way that I
Okay.
showed you. Okay, function notation. We were using slope-intercept form, y equals mx plus b. All of these lines that take on this form are functions. when we know something is a function, we can express it and let the reader know that it is a function. This says that y is a function, that's what f is, and it depends on whatever's in these parentheses here. Okay? This lets you know what it's going to depend on. So the y is a function that depends on whatever you put in for x. Okay? So f of x is the output, just like y is. These are the same thing. These are interchangeable. Okay? It means the same as y. What it is not, it's not f times x. Let me just say that now. This is not, it's on video, not f times x. This means function of x. Okay? This is a function depending on x. And then this part stays the same. Okay? And you can see that here. So this is called function notation. What it does is it lets the reader know that there's a predictability that exists. When you plug in an x, you're going to get out a y. You're not going to get out 2 y's. You're going to get out one answer. Okay? So that's what function notation is all about. Now, what I can do is I can give you an equation like this. I can say f of x is equal to 3x plus 4. There's your mx plus b. Find f of 3. What's f of 3? We said that this is a function of depending on x. Now I'm telling you what x is. X is 3. What is the output, f of 3, when the x is 3? So all you do is you plug in 3 for x. What's 3 times 3?
9.
9 plus 4.
13.
That's your answer.
Yay!
So this is a fancy way of saying, I'm going to plug this into my function machine. This is your function machine, right?
Yay!
Remember this, what we drew? You put in a 3. What did you get out? 13. So that's what that is. So that notation, when you say a function f of x is equal to this equation, this gives you the rule that you're going to follow to get your output based on whatever input you want to put in there.
So in speaking terms, you say f of x, not a function of x?
You can say either.
Oh, okay.
What you don't say is f times x. That's not.
Oh, okay.
Now look, watch this. I can change this up. I can put in a different input. Remember, we've just been talking about that. So if I put in a different input, even if I get the same output, that's okay, as long as I only get one answer, which linear equation is always going to give me one answer, as we saw. So when x is 5, you get 3 times 5, 15. 15 plus 4, 19. That means when x is 5, the only answer I can get is 19 out of that. Okay? Moving along. All right, so then they just have some of these other examples. We're a little bit over time, but go ahead and just try these two real quickly. We're almost done.
If function of x is
It is not f times 5. This is not f times 5.
20, 15,
You need this equation.
-6, negative. You can say negative.
For a, it's f of 5 equals 13.
F of 5 is a value. It is the output. This is your output. When, specifically when, x is 5.
Done.
5 is my input.
Yep.
Is the second one -6? It's kind of blurry.
Hold on.
Yeah, it's -6.
The glasses.
Times 4
Minus
31, -31.
minus 7.
Hey, there you go. There's the first one, 13.
I think 13, and then I think for B it's -31.
That's
Well,
what I got.
f of -6 means I have to go back to this one.
Because 4 times -6 is negative,
Yes.
negative 20, negative 24, and then
then
minus 7 is
Or
31.
plus -7. negative 31.
Exactly.
That's what F. So the
31.
input.
Oh yeah.
The input is -6. The output is -31. So x is the input. Oops. But f of x is the output. Okay. Output. Okay, I butchered that there.
So is the answer x equals -31 or
Oh,
f of
f,
x?
No, x
of-
is
f of
x is
negative
6.
6.
X is -6.
Oh,
F of -6 is
Is-
-31.
okay.
That would be your answer.
X is -6. Here, x is 5. The input is there. The output is the entire thing, is the output. And that's
So
what
you're like
f of
you're kind of substituting
is-
because you're doing like f of x is x it equals mx plus b, but then you're substituting.
So f of x is 31. Is
yeah,
the
Negative
answer.
31.
or remember, f of x.
Negative 31.
Wait
Yeah.
a minute, wait. F of x is y, right? F of x is
Yes,
facing
exactly.
y. So basically,
Yeah.
y equals -31.
Okay.
And then what is x? X. Oh, okay. X,
X
is
is
-6.
-6.
Y.
Yeah. Here, x is -6.
That's
Y
funny.
is this. Here, x is 5. Y is this. Okay. Now you're ready to probably go in and do that homework.
No.
Okay. So, okay, but they do apply it to a problem. Maybe I can start the next lesson with this. Yeah. So I can give you the homework, and then we'll start the next lesson with
that's
that as
bugging.
a warm-up problem. Okay? So go ahead and write that down. That will conclude this meeting.
Yay,
And
homework.
you guys have a
So
great
exciting.
weekend. You guys have a wonderful weekend.
You too,
And-
Mr. Rosenthal.
Thank you,
Stay
Mr.
home, stay safe.
Rosenthal.
And I will see you
Stay
guys all
healthy.
on Monday.
Thank you.
Be safe
Wait,
out
I have
there.
a question.
Sure, go ahead. Question.
If we end up continuing online learning until the end of school,
Thank you.
when will we take our tests?
That I will address sometime next week.
Online.
Well, thank you, Mr. Rosenthal,
Okay.
for your lesson. Have a good weekend.
Yesterday when it froze, do you know what
Thank you,
happened?
Mr. Rosenthal.
All right, everybody.
Thank you, Mr.
Well,
Rosenthal.
left the meeting.
Goodbye.
That's what
All
happened.
right, thank you, everybody.
Thank you. Thank you so much.
Have a good weekend, Mr. Rosenthal.
Have a great
Good weekend, Mr. Rosenthal.
Okay, I'm going to close it out. Have a great weekend.
Okay. You
Bye.
too.
Thank you,
Bye.
Mr.
Oh my God.